right, amides, our next functional group that we're going to learn to name. Amides are very similar to esters in their nomenclature because they resemble esters, right? So something like this, for example, we have the amide. What we do is we name everything on the nitrogen first. And we actually use the N as our locant, where we are having these things. So in this case, we would say N-ethyl, N-methyl, ethen amide. So the ending here, the suffix ending is amide, like it was before. Another very common solvent we have is N-dimethyl formamide. And so we will see that sometimes common names get in here. Technically, we would call this methanamide, but formic acid and formaldehyde, as we know, are common names. So we'll see those. So ideally, yes, you would call this N-dimethyl methanamide, but Iupac does allow for many common names for smaller substituents. If you have an amide as a not your parent name, if it's a prefix, it's easier to just say aminocarbonyl. Perhaps we're seeing a pattern for all these, right? And so you can name it that way. So let's say we had, oh my goodness, okay, how about we've got our, here, we'll just make it very simple. All right, so you would say in this case 2-aminocarbonyl ethanoic acid. So that works. So you'd find your highest priority functional group. That one becomes carbon 1. You would name your other substituents as substituents. So we would call this aminocarbonyl. And if we had other stuff on it, we would have to say, I'm sorry, this 2 should be outside the parentheses. 2-aminocarbonyl ethanoic acid. With this, we need to indicate if we have stuff on our end, for example, have our methyl groups there. We would say 2, we'd have our hyphen, N-dimethyl aminocarbonyl ethanoic acid. It just gets awful, doesn't it? No one likes these Iupac names, but we got to do them. So there we have it. So in the rare case that you happen to have 2 of these functional groups that are high priority, again, the acid is always number 1, then the ester, acid chlorides, amides, and as we'll see, our last functional group would be the nitriles. That we'll be studying here. All right, so amides, fun. Nitriles now. These are things with CN groups. Finally, we have a relatively straightforward prefix and suffix name. Prefix is cyano, as we would think, because it's made from cyanide, generally speaking, and the suffix is nitrile. So, hooray! And so these aren't too bad. Let's see. How about we have, no, let's do something like benzene, why not? This, we often compare these to aldehydes or carboxylic acids, right? The corresponding aldehyde or carboxylic acid would be benzoic acid or benzaldehyde, right? We call this one benzonitrile. So very exciting stuff. We can have something like a propane, we can say. We can say propanitrile. You do not need a locator number because it's assumed to be number one. If you've got two of them, this would be propane. You could say propan dinitrile. Propan 1,3-dinitrile. In this case, normally, you don't have to put the double N, but because we're separating these with locator numbers, we're going to need to do that. So, yay, nitriles. So, all of these are carboxylic acid derivatives, except for, of course, the carboxylic acids. They're all classified by having 3 bonds to heteroatoms. So all carboxylic acids and derivatives have 3C heteroatom bonds on the same carbon. So carboxylic acids have 2 bonds to the carbonyl oxygen, 1 bond to the hydroxy, so that's 3 CO bonds. Nitriles have 3 CN bonds. Amides have 2 CO bonds and 1 CN bond. Acid chlorides have 2 CO bonds and 1 CCl or 1 C halogen bond. So anything that has 3 carbon heteroatom bonds, they don't have to be the same heteroatom, would be considered derivatives. And we're going to see that their reactivity is going to be pretty predictable. They're all going to undergo very similar reactions as each other. And so we'll start taking a look at that in the next couple of videos. But first we'll review how we even synthesize them in the first place. And so we'll look forward to that.